Come on.
Hi, I'm Yali.
I'm Evan.
I'm Meg. I'm Audrey.
And we are Group 3! Before anything else, let's have a brief introduction about the experiment. When the moisture content of a dry sample of such a soil is increased, its state gradually changes from that of a solid to a semi-solid to a plastic and finally into a liquid form. The properties of fine-grained soils are heavily dependent on their consistency, which is related to the moisture content of a dry sample of such a soil. The consistency limits, or Atterberg limits, offer a way to quantify and describe the plasticity range in numerical terms, are the arbitrary borders separating these phases. Clay can be converted into slurry or the liquid condition by adding enough water to it. Slurry acts like a viscous liquid. The clay ultimately starts to hold together and start to give some resistance to deformation if the moisture content is steadily decreased by letting it dry out slowly. This is the plastic state. As more water is lost, the clay contracts and stiffens until there is minimal fluidity left, and the clay breaks easily, signifying the semi-solid stage. The clay continues to shrink as it dries, proportionate to the amount of water lost, until it achieves the smallest volume that can be achieved by this method. A soil's liquid limit is the water content at which it behaves almost exactly like a liquid while still having low shear strength. In the liquid limit device developed by Casagrande, it flows to close the groove in just 25 blows. Since it is challenging to obtain precisely 25 blows during a test, 3 to 4 tests are carried out in order to estimate the number of blows, or N, necessary for each test. Next, a semi-log plot between log N and the water content is created. The water content that corresponds to N is equal to 25 is the liquid limit, as shown by the plot. The standard reference used in this experiment is the ASTM D4318, or the standard test method for liquid limit, plastic limit, and plasticity index of soils.
Now, let's talk about the materials and apparatus used in this experiment. Let's first talk about the materials. In this experiment, we will be using soil specimen and some distilled water. For the equipment, we will be using sieve number 40 with 0.425 millimeter, evaporating dish, spatula, grooving tool, beam balance, a dropper, the Casagrande apparatus, and the last one is an oven.
So here are the procedures for this experiment. Around 120 gm, a portion of the thoroughly mixed material that passes through a 425 micron ISU yields air dried to soil. To create homogeneous paste, distilled water is combined with the soil that has been obtained in an evaporating dish. The paste must be of such a consistency that it would take 30 to 35 drops of liquid from a cup to close a typical groove sufficiently. Next, with a few strokes of the spatula, a quantity of the paste is spread into the cup of the Casagrande gadget. Make sure that it is cut into a depth of 1 cm at the thickest point, and any extra soil is returned to the dish. By making 4 strokes with a grooving tool along the center line of the follower, the dirt in the cup is separated, resulting in a clean, precise groove of the right size. When 2 soil cake halves have been in contact for a length of about 12 millimeters, the cup is dropped with rotating the crank at a pace of 2 revolutions per second by flow alone. Next, record the amount of blows needed to close the groove for approximately 12 millimeters. In order to determine the soil's water content, a representative sample is removed from the cup. For blows between 10 and 40, the test is run at least 3 more times with varying moisture contents. Let us take note of the following. Prior to testing, soil used to determine the liquid limit should not be oven dried. In the LL test, the soil's flow should close the groove rather than the soil slipping between the cup and the groove. After adding water to the soil sample, enough time should pass for the water to infiltrate the entire soil mass. The container with the soil sample should either be placed in desiccators or immediately weighed. Wet soil taken in the container for moisture content determination should not be left open to the air. The soil should be tested in drier, more drops and wetter, fewer drops conditions.
The ASTM D4318 standard test method for liquid limit, plastic limit, and plasticity index of soils is the normative reference utilized in this experiment. According to ASTM D4318, there are two ways that may be used to determine the liquid limit of the soil. Liquid limit method A, multi-point method, and liquid limit method B, one-point method. The earlier technique worked as well in this experiment.